Now, let's focus on finding the domain of functions. So, to find the domain of a function, that basically means to find all allowable possible x values that you can have in your function. As a quick summary, so domain of a function, all your inputs, all x's over which its function is defined, or all the valid inputs into f, where f spits out a valid output. Range of the function f is a set of all f of x or y values, where x varies throughout the domain. So all the values y, actually it's going to be f of x, that your function f takes on. Now, here's examples of the domains. We're going to have a look at the first type when we are given the polynomials. So the first example, y equals to x plus 3. So x could be any real number. So we could use this letter r that stands for kind of a doubled r that stands for the set of all real numbers. This is the typical notation for this set. Also, we could use the interval notation. So it's from negative infinity all the way up to positive infinity. So basically that means the set of all real numbers. So either way is fine. Second example, we are given a quadratic function and it's polynomial. So x could be any number. So it could be positive number, negative number, it could be 0, any number that you could think of. So the domain would be the same. And finally, the last example, we have polynomial with degree 4. Again, x could be any number. So the domain is going to be the set of all real numbers. Now, how to find the domain of functions? For any polynomials, the domain is going to be the set of all real numbers. So it could be any polynomial of any power or any degree. Now, let's figure out how to find the domain of algebraic fractions or rational functions. Say we have function f of x equals to x plus 1 over x squared plus 5x plus 6. Keep in mind that your algebraic fraction is defined for all real values of x except that values of x that make your denominator, the bottom, equals to 0. So in other words, we have to exclude the values of x that make your bottom equals to 0, since division by 0 is not permitted. In order to do so, you want to take the bottom and set it not equal to 0 and solve it for x's. In this case, we are going to pull out x squared plus 5x plus 6 and set it not equal to 0. It factorizes out into x plus 3 and x plus 2. Remember, this is a quadratic and we're looking for two numbers that multiply to the last constant, which is 6, and add up to the middle coefficient, which is 5. So it's going to be 3 and 2. So since 3 times 2 is 6 and 3 plus 2 is 5. Now, we want to solve it for x. So just set each factor is not equal to 0 down below and solve them separately. So it's going to be x plus 3 is not equal to 0 and x plus 2 is not equal to 0. So your x is not equal to, from the first one, negative 3, and your second x is not equal to negative 2. Now, these two values make your denominator equals to 0. So these two values has to be thrown out. So if you plug in this negative 3 and negative 2 into your fraction, you will get that your denominator is 0. So these two numbers, they create this division problem. So they have to be thrown out, excluded. So the domain is going to be all real numbers except this negative 3 and negative 2. So these two troublemakers, if you will. So they create this division problem. Perfect. Let's move on. The third type is when you are given a square root only, something like f of x equals square root of x plus 1. In order to find the domain for this type of functions, all you want to do is just take the underneath expression, radicand, and set it greater than or equal to 0. Remember, for a square root function, we have to claim that your radicand, your expression underneath the square root symbol, has to be greater than or equal to 0. For instance, say we have square root of x plus 1. So what is the domain of this function? So all we want to do again, just take this x plus 1, pull it, and set it greater than or equal to 0. And we have to solve this basic linear inequality. So all you want to do is just move it's really basic. All you want to do is just move this 1 to the right side by subtracting 1 from both sides. You end up getting x greater than or equal to -1. So your domain is going to be all real x's that satisfy this condition, x greater than or equal to -1. So also interval notation can be used to represent domain. So again, it's going to be -1, and notice I'm using the square brackets. That means that -1, the value is included in the domain all the way up to positive infinity. The fourth type is gonna be the most, I think, the most complicated one. Square root on the bottom of your rational expression, of your rational function. Say you have f of x equal x squared plus 2x plus 3 over square root of x plus 1, and we need to find the domain. All you want to do is just pull out the radicand, the expression underneath your root symbol, in the bottom actually, and you want to set it strictly greater than 0. Strictly. Why strictly? Because your bottom cannot be equal to 0. So remember, we have to exclude the values of x that make your bottom equal to 0. And since your expression appears to be under the root symbol, so we have to claim that this radicand has to be greater than 0, has to be positive actually. Alright, let's work it out. We're going to take this x plus 1 and set it greater than 0. This is basic linear inequality again. X is going to be greater than -1, and the domain is going to be all real values of x, satisfying the condition that x is greater than -1. So, or using the interval notation, is going to be the interval from -1, not included -1, all the way up to positive infinity. Perfect. I was lying, there is a 5 type, when you have square root on top of your fraction. To find the domain, first of all, you need to take the bottom and set it not equal to 0. And you want to set part under the square root, or it could be actually any even root. It could be 4th root, 6th root, greater than or equal to 0. And you want to take intersection. You want to solve them, these two conditions, simultaneously. Let's put it to the test. Say we have f of x equals square root of x plus 1 over x squared minus 4, and we need to find the domain of this function. All we want to do is just take the expression underneath the square root, and we want to set it greater than or equal to 0. So your x is going to be greater than or equal negative 1. And the second condition, we want to take the bottom, the denominator, and we want to set it not equal to 0. So we don't want these values of x that make your bottom 0. Now, we want to factorize x squared minus 4, and remember this is a difference of squares formula, so actually it factors out into x minus 2x plus 2. Now we are going to set each factor is not equal to 0, pull them down below and solve them separately down below. So x is going to be not equal to and x is not negative 2. Now, since your x, we have the first condition, remember, x is greater than or equal to negative 1. So we have to exclude, rule out the value of negative 2 from the solution, because negative 2 is less than negative 1. So this negative 2 has to be thrown out. And your domain is gonna be actually two intervals joined together. The first one is gonna be from negative 1, included negative 1, all the way up to 2, not included 2, because x cannot be equal to. So join, union, using set notation, set language, second interval from 2, again not included 2, all the way up to positive infinity. And remember, we did excluded this negative 2, so it's not in the domain. Perfect. Here's some problems for finding the domain of the functions. So I will encourage you to pause it and try to solve it. More? More problems?